So hello guys, this is Shreyas over here. Hello. Yeah, it's recording. Okay. So this is a library called as myvectors. So it has basically designed and developed by me. This myvectors package generally deals with vector mathematics. It's has simple basic vector functions. So it has been hosted on pypi and its name is myvectors, as you can see over here. Currently it's in version 0.9. When you go to release history, you can just see the previous versions and the dates accordingly. From version 0.1 to 0.9, it has come along a long way. Currently there are 5000 downloads over here, and as of today you can see uh, it has 5206 downloads. Okay, so coming back, yeah, so I will just go through a simple functions which this library can does. First, it can find the magnitude of a given vector, dot product of two vectors. Similarly, it can also find the cross product of two vectors, projection of vector b on vector a in this case scenario. So it is generally projection of vector a on vector a on b. So the first argument will be the projection on the second argument. Then it can find the angle between two given vectors points. Then say for example a triangle is present in a 3D space, 3D vector space. Finding then getting the coordinates of the triangle, you can you can trace the areas between area of that triangle. Then there is a special formula called section sutram. What the before that, yeah, yeah. The one specialty of angle is that you can find the angle in terms of sine or cos, and also in terms of radians and degrees by just changing these four things over here in the third and fourth argument. Next, coming to section sutram, it is of a simple formula which finds the ratio the point which divides two vectors in a given ratio. Okay, then yeah, there is a formula to find the points, three points are collinear or not. Then you have scalar triple product, vector triple product, and you can also visualize a vector in 3D space. This is one of the very interesting feature which has been added in this library recently in its 0.92 version. I'm going to show it with this same example, and it will be very nice to see it. So let's do some coding stuff, and let's see some of the examples for with this. So first we will install it. So you can I'm using collab over here. You can use any environment which you like. You can also go use Jupyter, Spider, or PyCharm, or anything. So first we will try to install it. Just say pip install my vectors. uh, yeah, it will take some time to install it. It says successfully installed my vectors. To just check, just try to import it. If it imports successfully, then it means that it has been installed. Okay, now I'm going to do a import function. Okay, so import function over here. So I'll just say from my vectors import star, so that I can directly use all the functions over here from the library my vectors. Okay, so first we will define a vector. So generally we are going to define a vector here in form of list. Say if suppose a is a vector with coordinates 2 comma 3 comma 4. So this generally means that the xyz of a is 2 comma 3 comma 4. Okay, so next so I just mention it over here. So it's a is equal to x comma y comma z. Okay, this means a is a vector with x comma y comma z as coordinates. Okay, so okay, this is in form of code. I just copy text. ओके, डिलीट करो बस इसको. ठीक है, Yeah, so now this is one of the vector with me, and I'm going to define. Okay, for time being, let's say this is a single vector with me, which says a equal to 2 comma 3 comma 4, and when I go to text, I'll try to find the magnitude of this vector first. Okay, so this is one of the basic functions which this library offers. It says mag of a, and when I say mag of a, you're going to get a direct magnitude of the vector. If you substitute the formula and solve, you are going to get the same answer. And over here you can see the library provides answers up to 4 decimal places. So next, let's try to find a dot product between two vectors. Let's say this a itself is a, one second, I just mentioned over here, dot product. Let's say a itself is one of the vectors, and next I will mention b to find a dot product, and let's say b is 1 comma 1 comma 2, 1 comma 1 comma 2. Okay, and to find a dot, I'll just directly mention dot a comma b. By doing so, you're going to get a dot product of two vectors. Yeah, that's it. If you just find using the formula, you're going to get the same answer. In the same way how we can find the dot product, we can also find the cross product of these two vectors. Let's take for example the same thing a and b. Okay, so for this I can try to find the cross, and we have to just mention it cross a comma b. Yeah, so these functions say this cross dot and this mag are all defined in the library myvectors. So, and that is the reason I am directly using those things, because I have done import star. I am directly able to use mag dot cross, or I have to do import myvectors as mv and mv dot mag or mv dot cross, all the other stuff you have to do. Okay, so next we'll try to find the projection over here. Okay, so projection. Okay, so coming to general syntax over here, speaking of the syntax, it's in the form of a projection is the function which is defined, and here you have vector 1 comma vector 2. So this basically says the projection of vector 1 on projection of vector 1 on vector 2. Okay, so coming to this, I'll say v1 is equal to 1 comma 4 comma 0, 1 comma 4 comma 0, and I say v2 is equal to 4 comma 2 comma 4. Okay, so next moving, I can say the projection, or I can directly say v1 comma v2. So this is going to give me the projection of v1 on vector v2. You can just google it, or you can solve it by yourself, and we're going to get the answer as 2.0. Okay, so next we will move to the next function. Yeah, this is one of the very interesting and one of the very best functions which this library offers. You can say this is the star mark function of this library, or you can also say this is the you the fabulous function this library offers, and that is nothing but angle. You may think that this is a very simple function this library offers, but no. The complexity to which this library offers this function is very good. You can very use it. You can use the way you want. Like the main star point which this library offers it, you can find the angle in terms of radians or angle, or sorry, degrees, or sine or cos. So you have the liberty, you have the freedom, whichever you want, whichever way you want, you can find the angle you want in terms of radians, you find it. You want in terms of degrees, you get it. You want in terms of sine cos, you get it. To just mention, first I just read the syntax so it is clear. Coming to syntax, so to just mention angle. Angle is a predefined function again which is defined inside the myvectors library. So first I'm going to mention vector 1, then I'm going to say vector 2. Yeah, now the third syntax is whether you want it in terms of sine or cos. Okay, and this is basically a string. Okay, so if you give sine, you're going to get the angle in terms of sine, or if you give cos, then you're going to get the angle in terms of cos. Now, yeah, okay. Now next thing is it's 0 or 1. What is 0 or 1? So if you give it is in terms of 0, then you're going to get the angle in terms of radians, and if you give 1, you're going to get the angle in terms of degrees. So you can get a angle between two vectors in terms of sine and radians, or sine and degrees, or cos and radians, or cos and degrees. What a fabulous function, man, to work with. So I just love this one of functions. This is my best function which this library offers. I have one more best function which this library has to offer. I'll show it at the end. So yeah, let's have an example. Let's take the same vectors a and b, which is already defined. Now let's try to find the angle between A and B in all the four formats. First I want to find with cos and radians. Okay. Coming here, I'll just write angle. I write A, I write B, and I write cos. Okay, then radians is 0. So this is the angle between A and B in terms of cos and radians. So let's take the same thing and do it for sine and radians. Okay, so you will see how beautifully this function has been written. By just changing some of the parameters, you're going to get beautiful results. Yeah, just add it up, you're going to get that 1 radian value. Okay, so it's very beautiful written. Now I'm going to show in terms of cos and degrees. Okay, so instead of radians I'll do it degree. Okay, and what you have to do, find in terms of degree. You have to just move the fourth thing as 1, the fourth argument as 1. Just hit enter and you get in terms the angle between A and B in terms of cos and degrees. How beautiful it has been written. Okay, so copy this and do it in terms of sine. Oh, sorry. Okay, yeah, do it in terms of sine. What you have to do, change the third argument. Instead of cos, do it as sine, and keep the fourth argument as 1 itself, because you want it in terms of degrees. Hit enter and the answer is 80.23. Now to check whether this function is really working, I'm going to just tell you, add this 80.2368 plus 9.7632, it's 90 degrees. You know, sine squared theta plus cos squared theta is 1. So in that way, in that formula, or by just adding it, when it sums up to 90, it means that yeah, it's working exactly right. So that's it. This is one of the best formulas, one of the best functions this library has to offer to you. Okay, next go into one of the formulas saying finding area of triangle through the vertices. Okay, so coming, let's say there is a triangle in vector space, in 3D space. Okay, and if you find then if you want to find the area, then just using, okay, the coordinates. Okay, just using the coordinates. So for this, let's say we have three vertices. Take t1, t1 is 1 comma 1 comma 1, and we have t2 is 1 comma 2 comma 3, 1 comma 2 comma 3, and you have t3. Okay, t3 as you say 2 comma 3 comma 1, 2 comma 3 comma 1. Let's take, these are the three vertices t1 t2 t3 of a given triangle in 3D space. If you want to find the triangle area, you have a direct function called as triangle area. Just mention it. Okay, triangle area, and just give the three vertices t1 comma t2 comma t3, and your work is done. That's it, plum. And the answer is in front of you. Take the formula, take the coordinates, try to find it, and you will get the same answer. So it's very pretty simple, it's straightforward finding the triangle area. So this is one of the best functions uh, also, but this is not frequently used, whereas this angle function is very frequently used by any vector solver. So, and here you have the flexibility to get the angle in terms of sine, cos, or radians and degrees. So this is one of the fabulous functions to go for. Yeah, so coming forward, you have section formula over here. So yeah, I just mentioned over here. Yeah, your section formula. Okay, section formula. So section formula is used when you want to divide a line joining two vectors in 3D space into a given fixed ratio. So I'll directly tell you the syntax, how it is. Coming to syntax, it is in such a way that it says section sutram, and you have vector 1 comma vector 2, and it says next it says I or E. Now this is also very interesting, I or E. Why it's saying I or E, I'll tell you next. Okay, next it has R1 R2. I'll tell you what is this R1 R2. Okay, yeah, I'll tell you now what is this third argument or argument. Okay, so this third argument is basically you give E if division is external, division is external. Okay, and you give I if it is internal. Okay, so depending on that you give whether it's I or whether it's E and blah stuff. Now R1 R2 is the ratio, R1 is to R2 is the ratio. Okay, so basically R1 is to R2 is the ratio. Okay, so we'll try to implement a simple example. So let us take that there are two things, 2 points in space, say s1 is 2 comma 3 comma 4, 2 comma 3 comma 4, and s2 is 4 comma 1 comma minus 2, and let's say r1 the ratio is 2 is to 3. So there are totally 5 sections and the ratio is 2 is to 3. Okay, so applying section sutram over here, you get s1 comma s2, and say if I want to do the external division. Okay, external division, and I say r1 comma r2, and when I run it, okay, int object has no, oh sorry, I have to give comma. Okay, yeah, so these are the points. uh, if you just plot it and see, these are the exact points when you divide the s1 and s2. This is the point 2.8 comma 2.2 comma 1.6 where the line sharing two vectors is divided in the ratio 2 is to 3 externally. Now the same thing we can also check it for internally. I'm going to just change the third variable from E to I. Okay, and you can see uh, the answer has been changed. So see, this way you can find the answer like uh, externally or internally. Okay, so next coming to check whether the points are collinear or not. Okay, to check if the points are collinear. Okay, so coming over here, there's a direct formula, and I'll just say if you have 3 points in space, say 1 comma 2 comma 3, and c2 is 11 comma 8 comma 12, 11 comma 8 comma 12, and if you have c3 equal to 10 comma 5 comma 7, 10 comma 5 comma 7. Okay, okay, so we have the direct formula, say collinear 3, and we say c1 comma c2 comma c3. Okay, now if the answer is 1, I'll say if 1, then collinear, if 0, non-collinear. Is as simple as that. Okay, so Okay, so next coming we have scalar triple product. Scalar S1 1 comma 2 comma 3. S2 is say 11 comma 8 comma 12. Okay, and say S3 is 10 comma 5 comma 7. Okay, and if you want to find the scalar triple product, okay, so just say S underscore triple pro and say S1 comma S2 comma S3. Okay, so depending on this, so minus 203. Yep. Yeah, this is, yeah, I know it's very hard to believe, but yes, take it from me. You put this three vector coordinates then and try to do it, solve it using formula, and yeah, this is the answer which you really get, minus 203. Okay, so next, going to vector triple product. Vector triple product. Okay, over here, so the formula we have is v triple pro, and let's take the same coordinates, s1 comma s2 comma s3. Okay, and we go next. Yeah, yeah, here you may be a bit convinced with my solution or with my approach, and these are the functions which are already predefined. Yes, triple pro, v triple pro, and all. Okay, so this is the coordinates which you get when you do the scalar triple pro. Yeah, now I'll show you the function which is the second best function which this library has to offer, and that is visualization of the vector in 3D space. Okay, this is the best thing this library has to offer. I'll just say I have a vector called as vector, and say for example I have it as 0 comma 0 comma 2. Okay, in z-axis it's pointing upwards, so 002, it's pointing upwards in z-axis. So now what I do is that I call a function called as draw vector. This is a very beautiful function and it's written very beautifully, and I just love this Python library because of two functions I'm saying, right? One is the angle and second one is this vector. You can actually see the vector in 3D space, and boom, that's it. Boom, 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 boom. Okay, yeah, see, this is the x-axis over here, this is the y-axis over here, and this is the z-axis over here. So when I say it's 2, then it's actually pointing towards 2. You can see it is actually starting. If you trace it, if you actually trace it, it's actually starting from point 2 with with plus of z-axis over here. And this is one of the very beautiful function this library has to offer. So just an example, you can just play around with the points x, y, z, and you can actually see the vector in three-dimensional space. What more do you expect from library? So one of the very beautiful functions. So looking forward, okay, so the function of angle and function of draw vector. Okay, so these are the two functions this library has to offer, and these are the very beautiful functions this two functions this library offers. Other functions are also there, but they are very beautiful functions. And yeah, you can to find more about this, you can go to their official page, myvectors. You can just type pypi. I'll just show you once again. I'll just type pypi. Okay, and pypi.org page will open, and just check for my vectors over here, my vectors, and my vectors 0.9 opens. Okay, and if you have any queries on this my vectors, you can you're always free to mail to this mail id shreyasmp1 at gmail.com. I'm going to provide this uh, notebook neatly designed, and in the description, and I'll also add the link to this library in this notebook also, and also in the description also. You can always contact from there. Okay, so thank you, Anadol, once again. Use the library. Thank you.